explanation. So first of all, the glucose is obtained from intestine and will be delivered in the cell, and it will be used by the mitochondria. So how we use will be explained furthermore. So first of all, for the first process, it's called the phosphorylation. So it means that the phosphor, it means that the phosphorus. So the phosphorus comes from where? It comes from the ATP that's been generated by the mitochondria, then be used again by the mitochondria. And also the ATP will be separated into two terms. That is, ATP means that for the adenine triphosphate, which is consists of the 3-phosphate group, it will turn into adenine diphosphate, which is ATP, and also the phosphate group. So the phosphate group will be used by the glucose to become a new compound, which is called the glucose 6-phosphate. This because this we're counting from the left side. We've got 1, 2, 3, 4, 5, 6, so 6 carbon, and the phosphate group attached to the number 6 carbon. So we call glucose 6-phosphate. So the process is called phosphorylation, and this process is consume the ATP. So the first process we use the 1 ATP. So the enzyme involved for this reaction is hexokinase. Okay, so the next process is called isomerization. So isomerization is a process where we change the structure of the original one. So in this case, we use glucose 6-phosphate to become fructose 6-phosphate. Glucose becomes fructose 6-phosphate. Okay, and then the next one is also called phosphorylation. So we use again for the ATP. So we have to use ATP from the first step. So step process, that the ATP will be converted into ADP and donate his phosphate group and can be attached to the fructose 6-phosphate into the first carbon, so which will become fructose 1,6-diphosphate. By means 2. So 2 will be one first carbon, one will be the 6 carbon. And the enzyme involved is the phosphorofructokinase. And the next one is to be cleavage. So cleavage is like to breaking down into 2 and not 2 into separate molecules. So for this one is equal. It's equal divided the 6 carbon into 3 and 3 into 2 other molecules. So the first one is the dihydroxyacetone phosphate, which is called DHP. And this one, due to its stability, is not very stable. So we will undergo the process, which is called isomerization, to become glycerol dihydride 3-phosphate, so become G3P. And another one will become another GTP, so become 2-GTP. Okay, so next one, the process is called oxidation and phosphorylation. So we look one by one. So the first one is phosphorylation. So we have to use the ATP also. So to use the ATP to add on the each. So become these 2 glycerol dihydride 3-phosphate when this compound is converted into this one. And another one will be converted directly into this one, so we have got 2. And each of these has 1 phosphate group. And through this phosphorylation, each of the G3P will add phosphate group from the ATP. So become 1,3-diphosphoglycerate. So it is number 1, number 2, number 3. So another process is called oxidation. So in the compound also, this one, it also donates is hydrogen ion. So oxidation in the chemistry terms is one of the chemistry terms in oxidation is we lose the hydrogen ion or hydrogen atom into another one. So this compound undergoes oxidation, and the hydrogen ion remaining will be given to the NAD+. So NAD+ is a coenzyme which it can be used in the electron chain reaction in the after the Krebs cycle. So involved in the electron chain cycle. Okay, so for the NAD+ is the oxidation agent, and also for the NADH is the reducing agent will be used in the electron chain reaction. And the next one, for the 1,3-diphosphoglycerate, we also use the ATP. We produce the ATP by giving one of these phosphate group, and number 1, the carbon number 1, the phosphate group attached to number 1 into to the ADP. So each one will produce 1 ADP. So 2 will become 2 ADP because the initially we produce 2 G3P. And then for the next one reaction is the structure level phosphorylation, which is one that this reaction will produce the ATP, because the ADP that will be used in the previously will become ADP. So ADP will plus with phosphate group that generated by the compound will become ADP. Okay. And the next one is the 3-phosphoglycerate. We undergo the process number 8, which is the isomerization. Also is the rearrangement of the substances into another one. So isomerization, we change the position of the phosphate group from number 3 carbon, become the middle one, which is the carbon 2 carbon, so become 2-phosphoglycerate. Okay, the next one is the dehydration, or we call condensation. So this means that condensation or dehydration, we remove the water. And because it's produced also 2 molecules, so we remove 2 water molecules. So remove water molecule, they will result in a phosphor inoperable, which is called the PEP. And the next one is the structure level phosphorylation. Also for the phosphate group that the remaining, the only one, the phosphate group attached to the number carbon 2, they will give the ATP. They will give the phosphate group, giving back the phosphate group to the ADP, so become ATP. So each one will produce 1 ATP. So 2 molecule produce 2 ATP. So finally it become pyruvate. And this pyruvate is the raw material that will be used in the link reaction. So the overall product that will be formed for this glycolysis is 2 NADH and also 2 H+, because they receive 2 and we will release 2 hydrogen ion. And also for the net is 2 ADP. Why I say so? This is because for the step 1 that we use 1 ADP, so we minus 1 ADP. And the step 3 we use again for another ADP. And the last several steps, that this one also for the structure level phosphorylation, they will produce 2 ADP from each respectively from the 1,3-diphosphoglycerate, so we become plus 2 ADP. And for the next one is also for the 2-phosphoglycerate, we release water, and also for the phosphonopyruvate, each one will also produce 1 ADP by giving this phosphate group into ADP, so become 2 ADP also. So we can calculate that we gain 4 ADP. And also for the 2 ADP that we have used in the previous one, so become 2 ADP loss. So the net one will become 2 ADP gain. So there's easiest way to remember the product of the glycolysis. So the first one is the G. The G become glucose. Become the glucose 6-phosphate. Glucose 6-phosphate for the first words in every words. And also for the F is fructose. Fructose 6-phosphate. And also for the forest F, also fructose, because this is substrate level phosphorylation, so you add on one more phosphate group into carbon number 1. And also for the G is called the glyceroldehyde 3-phosphate. And another one will be ignored because we will convert it into G3P also. That is the DHAP will become G3P because it's not stable. And the B will become your 1,3,1,3 diphosphoglycerate. And the P, so the P is the 3-phosphoglycerate, and this P will refer to the 2-phosphoglycerate because it undergoes isomerization. Number 3 become number 2 carbon. And also another P, which is called the phosphoenolpyruvate, and also the last one is pyruvate. So that's all from the summary of the glycolysis. So thank you.